I'm Jüri Toomessoo, and I'm the CTO of CDP Technologies. And what we do is we basically make a platform and an IDE to develop the control system user interfaces, and now we're also working to support cloud applications, because we have added like event-based compute into the framework, which allows doing quite nice website applications in the backend. And the reason I guess to be here is that we also support Raspberry Pi. We are free for non-commercial use. You can download if you want to try. You get a 30-day free trial without any license, and then you need to request a free home user license if you want to try it out longer. And there are actually no runtime licenses that are needed to actually or that cost anything, but there is still a license fee per application that needs to be requested. That's free, but for open and home users, we ask for the project to be open sourced and put somewhere like GitHub or something like that. So it's there for the community and for us to check out what people are doing. So those are the caveats of the non-commercial. And so I'll get on with this kind of I have few slides only to because the first part is talking about the use cases or where we have been used. It's maybe more interesting, and I have slides with pictures, and then there will be live demo of the framework and the IDE in actual action. So we have been used in many different projects, but because this framework grew out from Norway, Ålesund maritime cluster, many of the use cases over the years have been related to sea somehow. There are some exceptions. Lots of smaller companies lately now, after we have provided the IDE also. It started as a framework, and we have been working the last 8-9 years on the IDE part. Now it gets more use outside of the cluster also. So let's get started. So the first kind of project that I wanted to talk about is Odfjell Drilling, which is a large 90-ton heel compensated winch, electric winch with 8 electric motors. So there is redundancy in there, so motors can fail and the winch will keep working. It's used to do delicate seabed operations on, for example, wellheads, to put the Christmas tree on a wellhead, which is very mission critical operation. You can't really do any mistakes there. So basically the winch compensates the movement of the installation on top. So the load on the sea bottom doesn't move when the ship or the installation moves. And it was developed in 6 months, and largely because everything started in parallel. So the engineers used our simulator to build physical models to simulate the actual physical environment, and then built the control system on top of it, and used Unity 3D game engine to actually do the visualization and simulation environment, so people could actually see what's happening in addition to the physical simulation that ran. And basically they built up the control system before the actual physical equipment was ready. And as these bits and pieces arrived, they swapped out this software in the loop to hardware in the loop equipment. And basically, when there was time to deliver, everything was already pre-tested, all the corner cases, and people knew that it basically worked. It contained industrial PCs running redundancy in multiple levels, both control and the motor level, and UIs. Then another quite interesting project is that CDP has been used for is this kind of a large gangways. These are up to 50 meters extended that are used to service, for example, windmills. And these are compensated for ship movements. So basically, and it has auto landing capability. So basically, during the heel compensation or the motion compensation on. You point it towards the windmill, and on a camera screen, you press a finger on the place you want the gangway to land, and it will auto land in that location on the windmill. And you can do people transfer when ship is moving, and it compensates all the ship movements. So the tip of the gangway doesn't move, that's on the windmill. And again, this also contains redundancy because we are talking about people, user interfaces. So this is quite a large and interesting project. So we have been used for many mission critical things in the maritime industries, but we have also done our bit for the Hollywood movie industry. One special effect company contacted us because they wanted to do remote driving of stunt cars because they didn't dare to put stunt drivers so close to action. They wanted to crash and blow up things. So they started actually with a Raspberry Pi and small remote control toy car. And before they even contacted us, they had made that work. And I think we spent like 3 days with them in their the special effect office in Hungary. But sadly, we weren't invited actually into the movie set because everything worked and they didn't need any help anymore, which is a bit sad. But this is a pretty cool project when you retrofit old cars and run them. There's a driver board with a wheel and screens, and you just drive them from up to 2 kilometers away. And everything runs as a single distributed system with the car and between the car and board. So next and last project, maybe to mention, this is the latest also, is like a tipping crane for a galvanization line. And they needed a anti-sway functionality that was really hard to implement for themselves, and off-the-shelf hardware units were really expensive. And they were also looking for some new user interface. And then we implemented a open loop anti-sway block for them and did a demo project using this, showing how you can put this kind of a thing together easily. And they are actually doing also UI control. They have added predictive maintenance on top of it. There is a simulator that does the crane load simulation for testing. And you are using Vago PLC 200, which is a Linux-based PLC in the project. And this is the project actually that I want to show as a starting place to just show one project to show how the tool works. So I'll stop the presentation. I hope you all see this. So this is the IDE. When you start it up, this is what you see. There's a welcome mode, and you can create new projects, open projects, or connect to existing systems if you have a valid license or you are in trial. But under examples, there is this. There are many interesting examples that you can take a look and open and try. But I'll look into this anti-sway for a moment. And so when you open an example, you get typically multiple things. You get a help page that talks about the example a bit, which currently is not important. And you typically get a library or a system. Some examples only have a system, don't have a library. So the difference between library and system is that library is the place where you either make new blocks writing C++, make new blocks by adding some existing blocks into the block diagram and creating a API that has inputs and outputs, or write code. And the system project is the project that contains applications that can run on a single machine, can be distributed freely on network into different devices, and make up that functionality that you are developing. So to build it, you can typically just do build on the library and to run and connect on the system. But I want to actually show deploying to Raspberry Pi immediately in the beginning. So both the library and system project have this deploy configuration tab. And you can choose which targets you want to potentially target with this library when you build. So you can say that I want to do both Raspberry and Linux 64-bit. You can install more toolkits from a package manager. But I have these 3 installed at the moment. And now when you do build, it will actually build a native binary library for both targets. And I can then use it in my system. So this system actually uses this. And now on the system, there is also deploy configuration tab. And here you can choose and target your applications to devices. So by default, they're typically the network is selected on the loopback interface to not disturb the network. And you have for each application, you have a toolkit selected. So if I, for example, want to do a split and put one of the applications on a different device, then all I have to do is to get actual devices on the network. I have to select the real network interface. Then it will do a network scan using the default SSH22 port. And I have used some of these devices before. So basically, my Raspberry Pi is already paired. So typically what you do is just you enter username and click the pair button. It pops up the password dialog and then does a key exchange with the device. And then you can use it. So, but this is already there. So I can choose a device. And I would have to choose a Raspberry toolkit for that device. So now what I'm saying is that from the 3 applications that I have, one deployed to a Raspberry that's on this IP address. It will be put in this location. And these 2 applications, the UI and simulation applications, live on my local PC. And these are the location where the applications will be built and put. So and now when I do run and connect, it will actually build 3 applications, one for Raspberry, cross-compiling it to the Raspberry, deploys using rsync, and brings up all these 3 applications in the background. So the Crane app is now running on a Raspberry device, and the UI and sim are running on my local PC. And now you can go into the block diagram, and this is basically what you see. There is a Crane application UI that popped up for a bit, which is here, and there is a Crane simulation model. So, and most of this project actually is done in no-code development environment. So there is only few lines of code, and those are in these Crane simulation models. But everything else is actually just no-code. So when let's open some interesting bit up. What the application does, or what this Antisway anyway does, is it's a Gantry crane. It can move on 2 axes. You can move the whole crane, and you can move the grab on the Gantry crane like over the on the other axis. So we'll run some cable out, so it will be more impressive. And by default, the Antisway is off. So let's try when there is no Antisway compensation. I'll just move the grab. You can see the values real time changing here. I'll stop the grab. And well, yeah, the load will sway because I just stopped it abruptly. Now, if I want the Antisway to be turned on, so I just click this. The Antisway is now on. I can run the cable out again. Stop it somewhere here. And now you can look at this speed in and speed out values. So it will, when I start running it, the speed in will go into the maximum speed, which is like half a meter a second. But the speed out immediately does not. And this is what the Antisway block does. It basically applies the speed requests in some difference. So when the crane stops, the load does not start swaying. So when you look at this application, you can see that there are different kinds of lines here. And the line colors actually notate the type of the data moving. So these blue lines are single real-time values going between places. Ports like this one are interfaces or buses that contain multiple values. So if you go into something where this port is, you can see that there are actually multiple values taken out from this port on the use location. And the multiple values here go into some port, but only one line goes forward. And there's a multiplexer which chooses which data to use, the anti-sway or non-anti-sway. And again, port with a single line goes forward. So these ports are used as interfaces to just clean up the design. You don't have to connect so many lines going everywhere. There is a third data type that this project does not have, which is this message event-based data type, which is a kind of a salmon red color. But just looking at the colors, you can see what's typically going on. So this is like a short overview of actually building an application, deploying it into different controllers using Raspberry Pi. And the cool bit is that any of this data that you see here, you can actually add to our plotter. Let's add these to plots. There is an analyze mode that shows the values. I can make these fit. Let's scroll this a bit down. And I can actually run this again and fit it into the view. And you can actually see the real-time data that is coming from the Raspberry Pi at the moment, plotted onto the screen. So you can change also values. If you go somewhere, these configuration values that the blocks have, these can be changed real time to change system properties. But I will now show you how to make stuff yourself quickly, because there isn't that much time. So to make new projects, you typically can make libraries and systems in the welcome mode. Let's start with the library and show how you make let's choose existing version. We have a new version also. And you can add new stuff into the library. We have different templates for different purposes. You can read about them, but I'll use a component, which is basically a cyclic function block that has also capability of two-state machine. But the wizard generates a boilerplate code for you. And the only really important thing to know about component is that by default, it has only one state. That's the null state. And this process null is called cyclically depending on the running frequency of the block. Now, to get data in and out of your black box code block, you have to add some input-output primitives. And depending on the block, we have helpers for that. There is the CDP add menu. And let's add some signals, for example. Let's do an input signal in one. It generates the code for you as the variable creates it. There is a different view for this. So this is the block in the block diagram. I can add things on this level. So these are the resources where I can add stuff. Another signal. Let's do this signal as another input. Call it in 2 and call this, for example, out. So I have created a simple database API. I can press F2 to go to code, and it has created these variables here. So and then you can basically write your code. That's a slice of real time in 2. So something you can integrate open source, third party, your own C++ code, C code easily. And now when you build it, you will get your own resource. This C++ block is abstracted away, and you can use it in your system. So let's create the system also. Create the system. again, you have to check that the version of CDP is the same between library and the system. If you run into trouble, you can always upgrade libraries to newer versions. So, and this is my system. And when you look at resources, this should build it also. Okay, I already actually built it. So my resource is here, and I can drag in this adder, which is, it looks exactly the same as I made it. And to get some data in and out, we provide lots of different industrial protocols. Like for Raspberry Pi, we have GPI and I2C, Modbus, MQTT, IO, NMEA, OpenCUA. There's lots of different industrial buses, but I'll use a simple generator to just have some data, and you can connect it into a input, and it creates this continuation label. And this basically denotes that because it's running cyclically, and the order is that the sign is after adder, the sign will run after adder. So if you want the adder to use the data from the sign from the same cycle, then you have to order them so the sign runs before. And you can make the adder add something, and now we have a like really trivial, simple system. So that does something. So it adds together these two values. You don't, of course, have to make an adder because we have lots of under automation resource. We have lots of pre-made blocks that come from the automation world that are typically used. There is an adder. You can add these simple function blocks during runtime also into your project. So you can connect these up and basically make this do the same thing. So you can tweak your C++ application on that's running with your custom changes if you wish. When you stop it, you have the option to actually view changes that were made during runtime and either apply them or cancel. And this is really simple way to work. So to add UIs to the system, there are a couple of different ways we support UIs. So you can add a new application into the system, choose application, and you can choose the default application type that you get either as a console, which was the first default application, UI, which is a native UI, and the web UI. So I'll add a regular graphical user interface application. And when you activate it, you get the design mode enabled. So when the design mode is basically what you see is what you get, really simple user interface builder. So let's make something semi-reusable. So I'll drag in a widget as a container, and I will put a meter in it, add a layout. Sorry. Where did this go? This went too small. This is better. Go back and add a slider into the same layout. So I have a meter in the slider, and let's make the meter fit our data potentially better. So because the sign goes between -1 and 1. So let's do this, that I will change the meter. I can filter, and there is a minimum value that I can set on this. Let's say this, set this to -100. Let's set the slider to go between maximum value of slider. No, maximum value of slider on type is 100. This is good. So, and I will connect the meter to the sign output value, and I will connect the slider into the amplitude of the sign. So to do this, there are a couple of methods. All the widgets have different routing properties that you can set that bind the aspect of the widget into some control system value. So you can auto-complete it here. You can also go and copy it from here, for example, to copy, so design mode. No, we actually copied the wrong thing. You have to copy the path. Design mode, paste. This is the value, and we also want to get the amplitude. Copy. No, design mode. And the slider has also routing. Y amplitude, copy path. And this is the path here. So, so now I have connected the sign's amplitude and value into the meter. But the cool thing that you can do with this is that you can actually drag this widget into your resource bar, and it will be here, and you can rename it, for example, some sign control, and then you can use this and reuse it in your other projects if you want as a ready-made block, and also add a layout here so it fills the whole screen. So that's my UI. And now when I run this application, I get two native applications. It connects the UI into the control system, and it's very small because the default sign amplitude was very small, but they can increase the amplitude of the sign with the slider. So it's really easy to do these kinds of UI applications. And we also have different themes. So on the main widget, you can do select theme and, for example, switch to OpenBridge theme, and then you have an OpenBridge theme. And when you run it, you get an OpenBridge application. You can also add web UI into both native and regular applications. Just to add web UI on the application. You can confirm these are not that important. And now you have a web UI and design mode enabled for that. So you can delete the blank that is there, and we can reuse this sign block that we did. And now we have a web application. So we can run both again. And now it's in OpenBridge theme, the native application, because it changed it. And on this console application, on sidebar, on the application itself, there is this web URL, and you can click on this globus, and it will actually load and open this PAR web page and serve a web application from the control application, which basically uses a different theme, but they are connected to the same actual sign component in the control system. So they do the same thing, basically. There are many different integrations in addition available. So we have this API that the IDE uses to connect to the real-time applications running on the different devices of the network. We use a C++ client internally, but we also have, when you look into our context and help page, we have a configurator tool and different language clients. So we can actually use Java, JavaScript, or Python to connect into the control system applications. So we have like a third language or other language clients that are available. We are also now working on a Grafana data plugin that would allow you to actually connect Grafana directly into the control system if you wish. Also, we provide a logger that allows you to log real-time data. And when data is logged in the analyze mode, you can actually see the historical data for the signals that are added into the logger. And all you have to do is basically add the logger and add values then, because this currently is not active, this add to logger option. But when you have a logger in a system, you can add values to logger and they will be logged. So this, in very quick run through, is the introduction of making UIs and making control systems. And anything that you create here, you can easily just copy, go into library and paste, and you will get the reusable resource of the thing that you created in your application. So this is a quite nice way to do reuse in the control system. Yeah, but the half an hour is over. I guess we should be open for any questions.
I don't know if there's any questions in the chat. Got a chance to look. Yeah, that was covered at the beginning. So could you just mention again the licensing and the business model? I think that you mentioned at the beginning, but someone asked that in the chat.
So the license model is so that it's free for non-commercial use. You have a 30-day free trial anyway that you can use, so you don't have to ask for a license immediately. You can try it out for 30 days. Everything works the first 30 days. And then if you like it and you want to do some home or hobby projects with it, you can request a license and you will get the free development environment license. And if you want to run applications longer than 1 hour, then you have to, if you have on a free plan, you have to request them one by one and show the source code of the project for which you want the runtime licenses. But they are also free. And for commercial, there are like 3 separate tiers. There is a startup license, mid-tier, and enterprise. And also there, all the runtime licenses are free without limits. Startup is limited to turnover and up to 2 users. And the mid-tier doesn't have all the things, like you can't get simulator licenses, for example. But it's really simple monthly subscription that's paid yearly. On a startup model, I think you can do even monthly payment, but then it's a little bit more expensive. But it's all available actually on our website. So if you go to our website, then under pricing, the pricing model is super clear and described. So we don't have to really, we don't make a secret out of the pricing.
So there's also a question about what languages support. You mean like
so basically, you can make new blocks in C++ or this no-code editor. Basically, you can wrap C also in the C++, of course. Third language, or the external language clients that use this real-time API that we have, are Java, JavaScript, and Python. Those are open source projects available in both our GitHub and in repositories. That you can, for Python, you can use pip install, and on JavaScript, you can install with any pvist, I think. So those 3 languages are supported outside. We have even some examples for Python integration. So we can, one shows plotting values from real-time system with Python, and others shows sending mouse tracking information from Python to the control application.
Very cool. I had a question. In your control systems, what about logging? Like if I want to log all the variables, or I don't want to log the variables, how does that work?
So basically that works so that you drag in the logger. Now by default, you have a logger with our compact data store. You can change the data store by adding something like CSV data store or influx data store if you want to log into an influx database. And basically all you have to do is click on a value and say add to logger. Click on a value, say add to logger. And if you have multiple loggers, you can choose into which logger it goes. It makes more sense to put the logger in some container component. So call this loggers, for example, rename it, rename loggers.
I guess you've got some options for like circular buffers and things like that as well. Is that how that works?
Yes, you can configure how long the logger will. There are limits there on the logger configuration. You can do buffer span and can have a rotating buffers.
Yeah, so we have a question in the room here, just a sec.
ESP32.
Ask again.
Does it work with ESP32s?
No, basically the platform needs to be Linux ARM or Linux x86 or Windows x86.
Yeah, so.
Preferably with some network, because you typically deploy over network, but you can copy with SD card, because you can deploy the image locally and then copy it onto SD card and put it into some device. It doesn't have a network interface.
Another question. Do you have a list of all the repositories of the open source projects that utilize this that you can share that's listable somewhere?
There are not really that many open source projects that use this. Interestingly enough, people tend to use it, this home version, because typically the 1 hour run rate for many people is enough for the stuff that they do, I would guess. So they don't ever ask for runtime licenses. So so far we don't have that many open source projects, sadly. But we have our own repository. If you go into the homepage, scroll down, we do have GitHub, and there are projects in our own GitHub with the language clients and some examples.
Thank you. Anybody else? Any questions?
So another question for me is, so what's the most complex project that's been done then? How many of these blocks do you end up with in a very complex project?
So there are complex in different ways. There are distributed control systems that run up to more than 16 applications, different controllers in the network. These cranes and gangways are huge. I would say there are tens of thousands of blocks. They're all nested, they're structured, but there is a lot going on in those projects, because those are not really trivial problems to solve.
And how do they debug something like that? Is it essentially a bunch of prints?
So we do have a pretty cool tools for. So one debugging is that you can plot any value actually, and you can see what's going on.
Okay.
You can do step-by-step debugging with a regular C++ debugger, but most of the time, this real-time plotting of values from the system is more useful because you don't really disturb the system. You see what's going on with the data.
Right.
But we do have this configurator tool. This is a command line tool that allows you to build using a YAML syntax, a build system with YAML, or use Python to generate it. And you can use it also to apply tests. So you can build up configuration and define test cases that when you set these values and wait and set those values, you can assert that after some time, you expect some values to be in some places. So you can build these kinds of tests for your existing blocks. So typically blocks get tested up front. So you know that when you change something, the required behavior of the block does not change. So there is also a CLI interface for it. You can interface that into a Python. You can build whole applications with Python from some Excel file, for example. We have like a specification of a winch, and you have your own blocks, and then you take that spec in and generate the winch setup with a Python script, for example. There are lots of use cases for these kinds of scripting support.
Okay, and there's another question on the chat. So Julian asks, is it used for safety-related systems?
We don't have a SIL level. So typically there is some external SIL PLC that is used to do like emergency stop on things. But we have redundancy capabilities. So you can do redundant applications. And this is what's required on these equipment that handles people or does really delicate operations. So then you can basically, there is a duplicated network and duplicated controllers, and you can destroy or plug anything of those out, and until the half of the control system remains, it will work. So we basically protect against a physical failure of some part of the control system. Or application crash, God forbid, which shouldn't really happen.
Well, any other questions in there? Oh, sorry. Sorry, give you the mic. Over here without the mic.
If you're using several sort of Raspberry Pis to control some equipment, how do you synchronize them all so that they work at the correct time?
So it depends how synchronized you need them to be. It depends on your time criteria. If you don't do anything, then it will do best effort. So when the one Raspberry Pi gets the values and emits them, the backplane is UDP. It's really quick. So it's a sub-millisecond on local fast network. But you can set up synchronization, time synchronization between controllers, but you should do that in Linux because Linux has tools to do both interface binding to have multiple interfaces for failover, and you can do time synchronization between controllers. And the way the scheduler is set up, we use Linux real-time threads, and we have absolute time slots. So if you use Linux time synchronization, like this microsecond synchronization, to get the controllers on sync, then the time slot on both Raspberries will be the same.
Thank you. Thank you.
Any other questions for anyone? Just a question here.
Hi. Who would you say is your typical customer? Kind of, I mean, like, is the use case somebody who doesn't know how to code and so they want to make something, or is it somebody who does know how to code but they think they could do it faster or some other reason for using this?
Yeah, there are both. We cater both for automation people who are looking for a tool that isn't really bound to any one hardware manufacturer, because this block diagram is really similar to PLC function block diagram. So that is for sure one user group. There are users who want modern UIs or want better UI capabilities, because we also support theming. You can do your custom themes on the UIs. Develop using SVG your own themes. But we see in ours, we are part of a bigger industrial group, and we have our mother company who actually uses our product daily. And there are like hardcore C++ developers who make these blocks because you can invent your own semantics. You can invent your own kinds of sub blocks and the meaning, what it means when you connect them together. And then you can build your C++ application without actually writing any code. And it actually forces a better structure.
So did this start out as an internal project?
It started out as an internal tool in the beginning of 2000s. The framework itself, it used to be pure XML. So in the background, it's still all XML and C++ source and header files. The interface just makes that look nice and easier to use. So there are like all source files are Git committable and human readable that describe what the system is about and how it works. So basically, when you build a application with dependencies, that binary later, if you don't add any dependencies, actually does not need to change when you change the system behavior. The binary is actually the same. The whole system behavior is described actually in XML in the background. That is loaded on startup, and the model is built that runs.
Thanks.
There's one question in the chat, which was about, does this require anything special other than the normal Raspberry Pi, such as an industrial compute module?
No. The Crane, that application that I ran on a regular older Raspberry Pi that I have on my table. So there is some setup thing. If you want to use the GPI or I2C, you have to enable them. There are some, when you start an application up on a Raspberry Pi, the console tells you if you need to do something. So there is some security configuration to enable real-time threads that you should do, add to security limits. But it does this printout on the console of the application saying that you don't have these limits for this user, you should add them there, and then you get the real-time capability for the application. But other than that, not really. Yeah, rsync is needed. SSH port needs to be opened, but that's about it.
Very cool. Thank you very much. That was very interesting. I'm very impressed that your demo worked throughout it and halter and that. This must be a pretty mature product. Well done.
Yeah, it has been developed for quite some time. Yeah.
Yeah. So thank you very much.
Yeah. Thank you.
I know you can't see everyone here in the gallery, but there's I don't know, quite a few people here.
Mhm.
So thanks very much, everyone.